Hi students, today in class you practiced the skill of solving literal equations and you took your third quiz of Unit 2. You'll get those back next class, but today in Lesson 2.7 we're going to discuss what's called undefined fractions. This is actually a pretty simple concept and it's always asked about on the New York State Common Core Regents exam, and many students get these wrong. And I think it's because they don't really understand what an undefined fraction is. I think if you understand what makes a fraction undefined, getting these simple multiple choice questions correct will be easy for you. So I'm going to start with a little warm-up that I think will help you understand what an undefined fraction is. If you take a look at this first example here, it says divide 6 by 3. Well, you don't need a calculator to do that. You can just do that in your head. 6 divided by 3 is 2. Now, how can you check your answer? Well, usually to check an answer, we use what's called inverse operations. If 6 divided by 3 is 2, to check your answer, you have to see if 2 times 3, because multiplication is the opposite of division, is really 6. And we know it is. So 6 divided by 3 equals 2 can be checked and proven to be correct. In example 2, the same thing is true. 0 divided by 4 is... well, 0 divided by anything is just 0. How can you check your answer? Well, take the product, multiply by the factor of 4. Do you get back to the other factor of 0? And sure enough, you do. 0 times 4 is 0. So 0 divided by 4 equals 0 can be checked and proven to be true. But now let's take a look at this one. Divide 8 by 0. You may not have a calculator handy, but if you did, if you plugged in 8 divided by 0 equals, here's what would happen. The calculator would give you this word, error. Or sometimes, if you're just using a scientific calculator, it'll say divide by 0, error. Now, why does it do that? Why doesn't it give you an answer? Well, think about it. If 8 divided by 0 is some number, what would the check look like? Well, it would look like this. That number times 0 equals 8. Can you think of any number in the real number system that if you multiply by 0, you get back to 8? Well, no, you can't. That's impossible. Because when you multiply by 0, the product is always 0. So this is what we call undefined. Whenever you divide by 0, which means there's a 0 in the denominator or the bottom of a fraction, division by 0 is what we call undefined. So the types of questions they ask on a Regents exam, like I said, are typically multiple choice. For example, these directions say determine when the following rational expressions are undefined. Sometimes the directions may say, for what value of x will this fraction be undefined? In other words, you're looking for the value of x that will make the bottom equal to 0. It doesn't matter what's in the numerator or the top of the fraction. You're trying to make the bottom of the fraction equal 0 in order for the fraction to be undefined. So again, a fraction is undefined when the expression in the denominator is equal to 0. So let's start off simple with number 1. It says 3 divided by x. So for what value of x will this fraction be undefined? If I put a 10 in the bottom, is 3 over 10 undefined? No, 3 over 10 is 3/10. Remember, in order for a fraction to be undefined, there has to be a 0 in the denominator. Well, right now we have an x in the denominator. In order for this fraction to be undefined, x would have to equal 0. Pretty simple when the only variable in the bottom of the fraction is x. So let's make it a little trickier and look at number 2. 5 divided by x minus 5. We're trying to determine when the following rational expressions are undefined. In other words, when is 5 over x minus 5 undefined. Well, that would depend on what value of x makes the bottom equal to 0, because when the bottom's equal to 0, the fraction's undefined. Well, you could probably do this one in your head. You know the answer is x equals 5, because if you plug in a 5 for x here, 5 minus 5 would give you 5 over 0, and so the fraction would be undefined. But on a multiple choice question, that's perfectly fine to do that math in your head. But what if it were non-multiple choice? In that case, you have to show work. So we're going to finish these notes as if these were all, well, which they are, non-multiple choice questions, so you understand how you have to show your work. Determine for what value of x this fraction is undefined. Well, you're just going to write an equation. You're going to take the bottom of the fraction, x minus 5, and set it equal to 0. Because an undefined fraction is when the entire bottom of the fraction is equal to 0. You'll notice this is a pretty simple equation to solve. To get x by itself, you add 5 to both sides. You get x equals 5. That's your value of x. That makes this fraction undefined, because 5 minus 5 is 0. So now let's find out what value of x makes this fraction undefined. I know a lot of you might be thinking, well, Miss Edwards, I know it's 5 already, because 5 squared is 25, and 25 minus 25 is 0. But it's a non-multiple choice question, so we're going to take the time to show our work. We're going to take the whole bottom of the fraction and set it equal to 0. And when we solve this equation, we'll have the value of x that makes this fraction undefined. So our first job is to get x by itself. Add 25 to both sides. You end up with x squared equals 25. And to get the x completely by itself, because we don't want to know what x squared has to equal, we want to know what x has to equal. The opposite of squaring is square rooting. Taking the square root of both sides, you do get x equals 5, but there's actually a second answer here. And hopefully some of you were thinking about that as I was working through this problem with you. What other number, when you square it, gives you positive 25? Well, that's negative 5 also works, because 5 squared is 25, and negative 5 squared is also 25. So this one actually has two values that make the fraction undefined, because if you plug in 5 here, 5 squared is 25, and 25 minus 25 gives you a 0 in the bottom, making the fraction undefined. If you plug in negative 5 here, negative 5 squared is also positive 25, and 25 minus 25 also gives you 0. Now this next one, you'll notice there's a variable in the top. And a lot of students will make the mistake of saying, oh, what makes this undefined? Well, it would be x equals negative 4. Like I said before, it doesn't matter what's in the top of a fraction. The top of a fraction is not the part of the fraction that makes the fraction undefined. It's only the bottom you need to consider when you're asked about undefined fractions. And in the bottom of this fraction, we have 6 times x. Well, what would make 6 times x equal to 0? Well, I just set 6x equal to 0, and I'm going to solve this equation. Dividing by 6 on both sides, I get x equals, remember, it's okay to have a 0 in the top of a fraction. 0 divided by 6 is just 0. So that makes sense. If I do 6 times 0, I get 0 in the bottom of the fraction. So x equals 0 is the number that makes this fraction undefined. Looking at 5, it's okay that there's a variable in the top, because the top has nothing to do with making a fraction undefined. In order for a fraction to be undefined, whatever's in the bottom has to equal 0. So I'm going to take the bottom of the fraction, 4x plus 2 equals 0, and set it equal to 0. And then let's solve for x. Subtracting 2 from both sides, you get 4x equals negative 2. And then dividing by 4 on both sides, be careful here, it's not x equals negative 2. 4 divided by negative 2 gives you negative 2, but negative 2 divided by 4 is actually the fraction negative 1/2. So negative 1/2 is the value of x that would result in making this fraction undefined. And you could check your work. 4 times negative 1/2 is negative 2. Negative 2 plus 2 is 0. Now, this is a popular Regents problem, number 6. The question will say, for what value of x makes this fraction undefined? And kids don't see an x in the bottom. And so they automatically just take the top, set it equal to 0, and assume that's how they're going to find the value of x that makes the fraction undefined. Well, that's not true, because, like I said before, the top of a fraction has nothing to do with the fraction being undefined. It's the bottom of the fraction. Well, in order to determine the value of x that makes a fraction undefined, you would have to have a variable in the bottom of the fraction, and in this case we don't. We have a 7. You can never change a 7 to a 0. So here we could say the answer is the empty set, because there are no values of x that make this fraction undefined. This fraction will never be undefined because it has a constant of 7 in the denominator, and you're never going to be able to turn a 7 into a 0. Now, if it said 7x in the bottom, that would be more like this problem in number 4. And the x value that would make it undefined would be x equals 0, because 7 times 0 gives you 0. But when you just have a constant with no variable in the bottom, that fraction will never be undefined. So you could say the empty set is your answer, or you can say no value of x will make this undefined. Now, another way that they can ask you to solve these problems on a Regents exam is not to necessarily give the value of x that makes the fraction undefined, but to list the restrictions on an equation. Now, restrictions are things that x cannot be. So even though in actuality you are looking for the values of x that would make the equation or part of the equation undefined, if you're asked for restrictions, you're not going to write your answer as x equals some number. What you're going to do is you're going to write your answer as x cannot equal, because you're being asked for the restrictions. That's different than being asked for what values of x make the fraction undefined. If you're asked the question that way, you say x equals 5 makes the fraction undefined, for example. But if you're asked to determine any restrictions, you're going to write your answer this way. Here we have 2 different fractions, so we have to figure out the values that will make each fraction undefined, but we're going to list them like this. X cannot be and x cannot be. Well, in this first fraction on the left side, what value of x would make that 1 over x undefined? Well, obviously it's easy when there's just an x in the bottom. X cannot be 0. Because if x was 0, 1 divided by 0 would be undefined. The second restriction comes from the second fraction, x minus 2. If you take x minus 2 and set it equal to 0, adding 2 to both sides would give you a value of x equals 2. So x equals 2 is a value of x that makes this fraction undefined. But again, we're being asked to determine any restrictions. A restriction is basically stating what x cannot be. X cannot be 2, because if x were 2, in this fraction, you'd have 2 minus 2 in the bottom of the fraction, which is 0. So that's what we're going to do for these next several problems, is just give the value of x that makes, we're going to list the restrictions, or basically what x cannot be. So in this one, the first denominator is x plus 2. Set that equal to 0. Subtracting 2 from both sides, you get x equals negative 2. So our first restriction is x cannot be equal to negative 2. And in the second fraction, we have 3 over x minus 4. If we take that denominator and set it equal to 0, adding 4 to both sides, you get x equals 4. So x equals 4 means 4 is a value of x that makes the fraction undefined. But since we're being asked to determine any restrictions, we're going to list our answer this way. X cannot be 4. And I know you could figure those both out in your head because you know in your head that negative 2 plus 2 gives you 0 and 4 minus 4 gives you 0. But these are non-multiple choice questions, so yes, you do have to take your time to show this little bit of work. All right, in number 9, don't worry about the fact that there's a variable in the top because we don't care about the top when we're dealing with undefined fractions. We only care about the bottom. The bottom on the right side is 1 because 0 is the same as 0 over 1. So like our example where there was a 7 in the bottom, there are no restrictions on the right side of the equation. But on the left side of the equation, we have the denominator 2 plus x equals 0. Solving that equation, we get x equals negative 2. So if the question said, for what value of x is this fraction undefined, you would say x equals negative 2. But since these directions say determine any restrictions on the equations, you're going to write your answer this way. X cannot be equal to negative 2. In number 10, the only denominator we have to worry about is this one. If it's set equal to 0 and solved, you see x equals negative 3. So negative 3 is the value of x that makes this expression undefined. Again, since we're being asked to determine the restrictions, we write our answer this way. X cannot be negative 3. In number 12, the only denominator we have to worry about is x plus 5. Taking that denominator and setting it equal to 0, solving, we get x equals negative 5. So negative 5 happens to be the value of x that would make this fraction undefined. But again, since we're being asked to determine the restrictions, we're going to write it this way. X cannot be equal to negative 5. Now in number 13, there's two denominators. One has a 9 and one has an 8. There's no variable in the bottom of either one of these in this equation. So what value of x makes this fraction undefined? That's the empty set. There are no values of x that make this fraction undefined. Even though you have an x in the top of this fraction and an x in the top of this fraction, remember the numerator has nothing to do with a fraction being undefined. An undefined fraction is only undefined when the bottom's equal to 0. 9, the constant of 9 will never equal 0. The constant of 8 will never equal 0. So the restrictions are no restrictions. And you really you wouldn't even want to write x equals. You would just write there are no restrictions. And again, these are simple, usually multiple choice questions. So you wouldn't have to show work. You just need to understand that the bottom of a fraction equaling 0 is what makes that the fraction undefined. So last problem. Consider this equation 3x plus 9 over x plus 8 equals x plus 4 over x minus 3. We haven't learned how to solve this type of equation yet. And you may be saying, Miss Edwards, yes we have. That's a proportion. We can cross multiply to solve that. But when we would cross multiply, we would get x plus 8 times x plus 4. We'd have to double distribute, and x times x would give you x squared. I can stop you right there. You do not know how to solve an equation that has an x squared in it. You've only learned how to solve an equation that has an x to the first power in it. You'll definitely learn this year how to solve equations that have x squareds in them. They're called quadratic equations. But luckily, we're not being asked to solve this. We're just being asked some questions about this equation. Question question A says, is x equal to 5 permissible? Which means, could x equals 5 be in the solution set? Well, the only reason x equals 5 would not be allowed is if it made one of the fractions, either on the left side or the right side of the equation, undefined. So I'm going to take x equals 5, and I'm going to plug it into my first denominator, x plus 8. When I do 5 plus 8, I get 13. 13 is not the same as 0. You can certainly have a 13 in the bottom of a fraction. The only thing that would make it undefined would be 0 in the bottom of a fraction. 13 in the bottom is okay. So far, so good. But x equals 5 would have to make this fraction something other than undefined as well. So we've got x minus 3 on the right side in the denominator. If we plug in 5, we get 5 minus 3. And 5 minus 3 is 2. Well, that's not 0. You can have 2 in the bottom of a fraction. So is x equals 5 permissible? Yes, it is. And that's because x equals 5 gives you a number other than 0 in the bottom of both of those fractions. We don't need to plug it into the top because what happens in the top doesn't matter. Now letter B, which values of x do you know must be excluded from this solution set? Well, it would be the values of x that make the fraction undefined. So looking at that first denominator, x plus 8, set it equal to 0. Subtracting 8 from both sides, you get x equals negative 8. And taking that second denominator, x minus 3, and setting that equal to 0. And solving that little equation, you get x equals 3. So those are the values of x that you know have to be excluded. Why? Because x equals negative 8 or x equals negative 3. Sorry, x equals positive 3. Would make one of the fractions undefined. Okay, so this is what we're going to practice when you come into class next time, whether that's tomorrow or the next day. We'll practice this concept of undefined fractions, and then we're going to move on to some review of the things we've learned in Unit 2 so far, so that we can finish up the unit with what's called inequalities. So have a great night, and I will see you next class.